Good morning, everybody. Happy Tuesday. So today we are going to start with the question, which property is illustrated by the picture? So which property that we discussed yesterday, commutative, associative, or distributive, is illustrated in this picture? Is it A, associative, B, bracket, C, commutative, D, distributive, or E, none of the above? If you pick commutative C, you are correct because the commutative property, if you remember, means that the order of the numbers does not change. So where I have 2 times 6 equals 12 on the left-hand side, 6 times 2 also equals 12 because of the commutative property. Okay, so moving on, we're going to first watch this video and then we'll get started with our lesson.
Once upon a time, in the magical and very round land of Pi, there lived 6 swashbuckling musketeers. Their names were parentheses, exponents, multiplication, division, addition, and subtraction. But each was known best by his or her mark. The 2 hands ready to catch a fly of parentheses, the small and raised digits of exponents, the mighty X of multiplication, slash of division, plus of addition, and well, you can guess the symbol by which little subtraction was best known. The land of Pi was not necessarily the most peaceful place, and that's why the numbers of the kingdom needed the musketeers. The land of Pi had been ruled by the numbers, as an anarcho-syndicalist commune, each number with a vote, but one powerful number from what we'll call the Imperial Senate engineered a war between some robot things and the knights of the kingdom, and then installed himself as supreme emperor. And then Puff the magic digit dragon ate him. And a princess or two. And, well, all the other numbers in the land of Pi actually. It was kind of a big day. Anyway, the musketeers were called to action to save the land of Pi from the voracious dragon. They rode towards him on their valiant steeds and attacked. First multiplication, then parentheses. But that didn't work. The dragon continued eating people. So addition tried, but was thrown aside. Exponents leaped at the beast, and was quickly squashed. Nothing was working. The musketeers huddled and formulated a plan. They would attack in sequence, but who should go first? They bickered for a while. The dragon ate a few more princesses, and then they finally agreed. They jumped into the first, smallest parentheses inside the great Puff the Digit Dragon. Parentheses pointed out where to work first and protected exponents, multiplication, division, addition, and subtraction while they diced and sliced. First here, then move over there, then there. Look out, there's another set. Parentheses pointed and exponents took the lead. Then it was multiplication, division, addition, and subtraction, each in turn, always the same order, P-E-M-D-A-S. When they finished that set, they went to another, and another, always working inside the parentheses in PEMDAS order. Pop, 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 pop. PEMDAS, there's another spot! Don't forget there can be parentheses inside parentheses. There's one. And that tricky exponent. There we go. Finally, the PEMDAS musketeers had whittled Puff down to his last fearsome roar. But having vanquished Puff the magic digit dragon, all the Empire's numbers sprang again from this tiny little number 1. And they all lived happily ever after. Except for the Emperor number, which they threw into the mouth of an ancient creature nesting in the desert. The end.
All right, so moving on. Today we're going to talk about something called the order of operations. Now, when we follow things in order, that means we're doing it step by step by step. So the order of operations involves going step by step by step when we're solving a math problem. But first, I need to introduce you to somebody. This is Aunt Sally. And Aunt Sally is a little crazy. She's just special. But a lot of the things she does they're kind of embarrassing. Like, she yells at people on the phone sometimes. Her facial expressions are kind of rude sometimes. And then here she is going after her neighbor and sticking her tongue out and being rude. So, like I said, it's embarrassing. And my family has a saying, we all have a saying that, please excuse my dear Aunt Sally. Just, you gotta let her be. Just bless her heart, Aunt Sally. But we can use this saying to help us remember the steps of the order of operations. So the first word, please, actually stands for parentheses. And we know what parentheses are. They're the C-shaped brackets that go on the outside of problems. And you probably recognize these from our ordered pairs. Our ordered pairs go inside parentheses. So P in please stands for parentheses. And we have excuse, which stands for exponents. And exponents are the tiny little numbers that you sometimes see in the upper right-hand corner of problems. And all that is telling you to do, that exponent tells you to multiply that base number that many times by itself. So 6 to the second power, or 6 squared as you might hear it, is just 6 times 6. But you'll begin seeing exponents in 6th grade. We really don't mess with them in 5th grade. Now the next two letters, ma and dear, or the next two words, go together. They stand for multiplication and division. And it's a common mistake to think that multiplication always comes first when dealing with problems in the order of operations. But that's not always the case. Because we solve math problems just like we read from left to right. So if we come across division before multiplication, we have to do that division problem first. So we move from left to right, and whichever comes first, either multiplication or division, that's the one we do. And then finally, Aunt Sally, that stands for addition and subtraction. And just like multiplication and division, it's a common mistake to think that addition always comes first. It doesn't. So again, moving from left to right, if you come across subtraction before addition, then you solve that problem first. So let's look at some of our problems that we can solve using the order of operations, using that expression that my family uses to, please excuse my dear Aunt Sally, whether she's yelling at people on the phone like I showed you before, just, ooh, Aunt Sally. All right, so let's look at this problem. I have 4 plus 2 times 3 minus 7. Now you will notice that I have color-coded the different parts of my problem based on the steps in my order of operations. So I'm always going to start with my parentheses first. So I have to start with 4 plus 2 because it's inside my parentheses. So when I solve 4 plus 2, that's going to give me 6. I'm going to bring down my 6 and copy the rest of my problem because I still have to work it out. Now, moving from left to right, the next thing I come to is 6 times 3. So I multiply 6 times 3 to get 18 and bring down my minus 7. So I'm left with completing 18 minus 7, and that gives me 11. I like to refer to this as a piece of pizza, a pizza slice. So you can see that at the top is wider and then it gets more narrow as it comes down to a point. like a pizza slice or an upside down triangle. Let's look at another one. 15 minus 8 minus 5 times 2. So I have to do my parentheses first. So I have to complete 8 minus 5. So 15, I brought down my 3 from 8 minus 5 times 2. Following my order of operations, multiplication comes next. So 3 times 2, that gives me 6. So the last problem that I'm having to solve is 15 minus 6, which is 9. Now I have 5 plus 10 minus 2 divided by 4. Have to do what's in my parentheses first. So 10 minus 2. Once I bring my answer down, I have 5 plus 8 divided by 4. According to my order of operations, I have to do 8 divided by 4 next. Bring down that answer, so I'm left with 5 plus 2. And the answer to my problem is 7. Let's do another one together to practice. This problem, I have 2 sets of parentheses, but I have to work from left to right. So I have 6 divided by 2 plus 2 times 10. So working from left to right, I come to 6 divided by 2 first. So I have to solve that, and I end up with 3 plus 10 times 2. So moving left to right, I still have parentheses, so I have to solve 10 times 2. And now my problem reads 3 plus 20. That's the last thing I have to solve. So my answer is 23.